And it's my pleasure to welcome you to the first in-person meeting. And it's a special pleasure to welcome Gail Wise to give the first beginner session of the new era. How's that? We'll close that. Put this on. Do you want the mic? No, you don't. It's very awkward, right?
Am I on? Can you hear me? Yes, all righty. We're not on.
Was there?
There it is. All righty. Lyra is a very little constellation, but it sure has a lot going for it. It's very easy to identify. It's shaped like an equilateral triangle. Oh, I borrowed this from my cat. Mouse, star, fly, and the face, mouse. Okay. It's an equilateral triangle attached to a parallelogram. It covers an area of 266 degrees and it has 45 stars brighter than 6th magnitude. Lyra has the brightest star of the summer sky, which is Vega, which is one of the stars of the summer triangle. It's the 6th brightest of all the stars, just in case you're keeping track. Vega, along with Deneb and Cygnus, make up the summer triangle. And on earlier sky maps, Lyra was a vulture, and along with the other two birds, it's being hunted by Hercules. Incidentally, Vega should be pronounced Vega or Wega or Wiga or something. I'll never get used to any of that. Its name comes from the Arabic for the swooping eagle of the desert. Vega is about 3 times the size of our sun, and it's 4.5 million kilometers away in diameter. It has a blue color, which you can easily see when you look at it with binoculars. As stars go, Vega is fairly close to us. It's only 26.5 light years away. But remember that light can travel a long way in a year. Its absolute magnitude is 0, and it's 58 times as bright as our sun. During the course of precession, which is the slowly changing orientation of the Earth's axis, Vega was the pole star 12,000 years ago, and it will be again in the year 12,000. Our solar system is moving in the general direction of Vega. It's a speed of about 12 miles per second. So at our speed, it would be about 45,000 years before we get to Vega, but by the time we did, Vega would be long gone because it's moving too. And Vega is usually the first star that we see when it starts to get dark. It was the very first star to have its picture taken on July 16th, 1850 at Harvard College Observatory. This process used a glass plate dipped in a solution of gun cotton and various iodides and bromides. As soon as this dried, the plate was dipped into a solution of silver salts. The plate was then used while it was still wet. Now just imagine how difficult this process was to carry out. A lyre is not somebody whose pants are on fire. It is an ancient musical instrument. It was invented by the sun god Apollo when he strung strings across the back of a tortoise shell. Now, you know, I don't mean a tortoiseshell cat, I mean a real tortoise shell. Apollo gave the lyre to his son Orpheus. Orpheus and Eurydice were young, and they were so in love that they were practically inseparable. Each felt that they could not live without the other. These young lovers were very happy, and they spent their days frolicking in the meadows. Orpheus was a great musician. His singing and playing were so beautiful that he was able to charm the wild animals with his songs. Flowers followed him wherever he went, and even the rocks gathered around and were softened by his notes. It is even said that he once attracted a row of oak trees to the river with the music of his lyre. Orpheus and Eurydice got married, but they were married for only 1 year and 1 day when she was attacked by a shepherd in a fit of passion. Eurydice ran away from him, but she stepped on a snake. She was bitten in the foot and died. Orpheus was devastated, unable to live without his young wife. He decided to look for her in the underworld, and he gained an audience with Pluto and Persephone. The king and the queen of the underworld, like everybody else, were charmed by his music, and they granted him permission to take Eurydice up with him to the land of the living. I don't know why he's carrying a fiddle there. Maybe lyres are too see-through. I don't know. They called Eurydice. She came from among the newly arrived ghosts, and she still limped because of her injury. Orpheus was permitted to take her up with him, provided he did not look back at her until they reached daylight. Orpheus readily accepted this condition, and he led Eurydice up through the dark passage to the upper world, strumming his lyre to guide her. It was a scary feeling to be followed by a ghost. He could never be quite sure that his beloved was following him, but he didn't dare to look back. Eventually, as they almost reached the surface, his nerve gave out. He turned around to make sure that she was still with him, and at that moment, she slipped away. Orpheus stretched out his arms to catch her, but he touched nothing but thin air. Desperately, he tried to rush after her, but he was not allowed. Orpheus was forced to return to the earth alone. Eurydice, dying a second time, she had no complaint against her husband. What was there to complain about? She had been loved. With a last farewell that barely reached his ears, she slipped back into the place from which she had come. Poor Orpheus was heartbroken once again. He wandered the countryside, mournfully playing his lyre. Many women offered themselves to this great musician, but he was so unhappy that he rejected their company. Playing, always playing, and the rocks and the flowers and the trees, they heard him gladly. They were his only companions. But the women were offended at being rejected by Orpheus, and they ganged up on him one day as he sat singing. They threw rocks and spears, and at first his music charmed the weapons, and they fell harmlessly at his feet. But soon the screams of the women drowned out the magic music, and the missiles found their target. Orpheus went to the underworld to spend eternity with Eurydice. He found her and embraced her with open arms. They roam the happy fields together now, and Orpheus looks at her as much as he wants to, with no penalty for a thoughtless glance. Zeus, the king of the gods, was so impressed by this wonderful, beautiful love that he placed Orpheus's lyre among the stars. And it is said that when you hear music that mourns lost love, it is the spirit of Orpheus who guides the hand of the musician who plays it. Wasn't that sad? Lyra has a few nice double stars. Beta Lyra is an eclipsing binary. It's about 962 light years away from us. And this actually is a triple star system. It's eclipsing binary and a single star. Of the binary pair, the primary has a magnitude of 3.5 and the secondary is 3.1. But that varies because they eclipse each other every 12 days. The two stars have distorted the two stars are very close and very close to each other, and they've distorted their stars into egg shapes as they rotate around a common center of gravity. There is a sparse open cluster of stars located about 1,220 light years away from us. At the center of the cluster is the star Delta Lyrae, so it is obviously called the Delta Lyrae cluster. It has about 33 members, brighter than magnitude 5.5, and it has a total magnitude of 3.8, and its diameter is 20 arc minutes, so 2/3 the size of the full moon. The star Delta Lyrae is easy to split. It has a separation of 10.5 arc seconds, and the two stars have a nice color contrast. They're orange and blue. Their magnitude of the two stars are 5.6 and 4.3, so you can easily see them with binoculars, and a telescope will split them nicely. It's about 800 light years away from us. and it's one of the nearest open clusters to us. It contains a large number of blue and white stars, which suggests that it's one of the youngest open clusters. I found this goofy table showing the time that it would take to get to Delta Lyrae. Now, the travel time in years is normal years, not leap years, so 365 days. And the New Horizons space probe here, that's the one that was sent to Pluto in the year 2006. And at the time, it was the fastest space probe that was sent out. And at that time, Pluto was still a planet. I don't know why this information was important to anybody, but somebody made up the slide and put it on the internet. So I guess it was important to somebody at some point. Epsilon Lyrae is the famous double-double. It's very easy to split into two components. The two primaries are a naked eye double, and it's a really good test of your telescope to split these two into four. All the stars are fifth magnitude and all the stars are white. Binocular shows Epsilon Lyrae as two stars at one time, but look more closely with a telescope. You will see that each of the two is itself a double star. And that's why Epsilon Lyrae is famous for being called the double-double star. It's a single point of light to the eye, but it's really four stars in one. One stellar pair circles around the other stellar pair in an intricate gravitational dance. Epsilon was first discovered by Sir William Herschel in 1779. And this is one of the most famous examples of a double star system. It's not just a line of sight effect. These stars are really orbiting each other around a common center of gravity. The stars are a great distance apart, and they take millions of years to revolve around each other. There are actually at least 5 stars here, but really I'm not going to get into all that tonight. And of course, the most famous object in Lyra is M57, the famous ring nebula. This is probably the best known example of a planetary nebula. The term planetary nebula has actually nothing to do with planets. A typical nebula will look like a glowing disk resembling Uranus or Neptune in a large telescope. M57 was the first one to be discovered in 1779. In a 3-inch telescope, it looks like a perfectly round disk about the size of Jupiter. Its diameter is almost 80 arc minutes and its magnitude is 8.8, so you can see it easily with a 6-inch telescope. Larger scopes will show a smoke ring in space. And in Japan, they call this the Donut Nebula. With a 20-inch telescope, you can see the central star, which is 15th magnitude. Okay, I'll say it. Lyra is known as the Tim Hortons constellation because it has a donut and a double-double. M57 is very easy to find. It's right between beta and gamma, just a teeny bit closer to beta. And with planetaries, it's difficult to know their exact distance, but this one appears to be about 4,000 light years away. The ring is about a half a light year in diameter, and it's 50 times as bright as our sun. M57 is the evidence of the death of a star. The central star in its dying throes has become unstable and has flung out an expanding shell of dust and gas. The ring appears to be expanding at a rate of 12 miles per second, which would make it appear to be about 20,000 years old. And this explosion was not like a supernova, more just like a mass ejection from a blue dwarf star. Another nice Messier object in Lyra is globular cluster M56. This is one of the less bright Messier globulars. Its magnitude is only 8, and it has individual stars ranging from magnitudes 11 to 14. M56 is one of Charles Messier's original discoveries on January 23rd, 1779. This is located about halfway between Gamma Lyra, which is that one, and the beautiful double star Alberio in Cygnus the Swan. This one is a challenge to find because it's quite dim, and it does not have a very bright core. In large binoculars, it appears as a fuzzy patch, and sort of as an out-of-focus star. The cluster can be resolved with a telescope with an aperture of about 8 inches or more. A 4-inch telescope shows just a round ball of light. but it doesn't really reveal much detail. Visually, observers can only see the cluster's central region, which is about 3 arc minutes in diameter. The best time of year to observe M56 is during the summer months, and M56 is 8.8 arc minutes across. NGC 6791 is an open cluster, which is easy to find. It's near Theta Lyrae, which is a bright star. It's that one right there. This is the oldest known open cluster. It appears to be about 9 billion years old, which is the same age as the youngest of the globular clusters. It has around 100 stars of magnitude 16 and 17, and its total magnitude is 9.5. NGC 6703, which is that one, is magnitude 12.3, and it's an elliptical galaxy. It's 8 arc minutes, it's 2.7 arc minutes by 2.5 arc minutes. This is the largest and the brightest galaxy in Lyrae. It's the only galaxy in Lyrae that's brighter than 13th magnitude. And this one is 80 million light years away from us. And right beside it is NGC 6702, that little guy up there. And its magnitude is 13.3, and it measures only 1.9 by 1.5 arc minutes. And these two galaxies are not gravitationally connected. They just look like they're beside each other. Lyrae also offers a meteor shower, the appropriately named Lyrids, which peaks on April 21st or 22nd. Under a dark sky, you should expect to see 15 meteors an hour, which is 1 every 4 minutes, so it's not that bad. It's certainly worth taking a look. And as with most meteor showers, the peak viewing time would be before dawn. The radiant is the point from which the meteors appear to originate, and this will be high in the evening sky in the constellation to the northeast of Vega. But don't look directly towards the radiant, because then you'll miss the meteors with the longest tails. Lyrid meteors are little pieces of comet Thatcher, which is a long period of comet that orbits the sun once every 415 years. Pieces of debris left in the comet's wake, however, make an appearance every year. The Lyrids are one of the oldest recorded showers, with observations going back to 687 BC. And you don't need any kind of special equipment to watch a meteor shower. Just look up at the dark sky, be patient, and enjoy the show. And Lyrae plays a part in one of the few star legends that comes to us from ancient China, about 3,000 years ago. It is the story of the shepherd boy and the weaving girl. Vega, there, is the weaving girl, and Altair is the shepherd boy. These young lovers neglected their duties to heaven, and so they have been banished, separated by the river of the Milky Way. In China, however, there is always compassion. Once a year, on the 7th night of the 7th moon, a flock of magpies gathers to form a bridge across the celestial river, and the young lovers are allowed to meet. The end.
Thank you. Any questions for Gail? Ed? Yeah, Catherine would like to call you because she doesn't have any sound.
She's okay.
Okay, just making sure. Okay. So it's my pleasure to chair the meeting today for Dennis. What's happening here? Go away. Okay, so this is the first time we've met for, I think, since March 2020. And also the first time we've ever launched a hybrid meeting, putting together the real-time Zoom meeting so we can see chat questions and an in-person meeting. So it's quite exciting, and I think took only 3 brilliant people to set it up. So hopefully we'll get experts galore at that and be doing it better next time. I should welcome you to the meeting formally and give call out to this being the meeting on the traditional lands of the Cree, Oji-Cree, and Anishinaabe, and the homeland of the Métis Nation, and something to the effect that we respect these peoples and respect what they do with the land and hope to use it and work together. I have a few announcements and then some information for you. So we've been working on bylaws revisions. There's been a committee working since January or February, and we will be having a vote on those revisions to the bylaws that were passed last AGM at the September meeting. So these bylaws are on the website, posted for members, and you can ask questions in the chats there or send an email to someone on council. We have a financial policy in the works, and this is almost complete, and Dennis will be telling you about that at a future meeting or in a newsletter. The RASC list, which is one of the communications arms by email by which you previously were seeing people post pictures and things like that and asking questions, will be retired on August 22nd, and it is replaced already in active mode by a groups.io email list. So this is the list by which you will receive the official notices from RASC about meeting times, places, regulations, votes, annual general meetings, and important events. And if you have any trouble, there are instructions on our website about using that group system. We would like to invite people who are interested in speaking to the group at one of our regular meetings to volunteer to present some topic of interest to them or others. This has always been a useful way of getting to know people and stimulates a lot of interaction amongst the members, because people actually finally figure out what somebody likes to talk about or think about. And so helps you get to know somebody really well. It also breaks the pattern of presentations being from what you might call the same people all the time, if that's the case. We do try to change it up a lot, but sometimes we do run a bit short of main speakers for the meetings. We have a loaner scope program that people are likely aware of, but new members may not be. There are 5 or 6 scopes and binoculars that you can borrow on a monthly basis, and Mike Caracas is our loaner scope coordinator. And there's also a binocular interest group that's led by Darren Hennig, quite active, at least in the darker part of the year, darker sky part of the year. And First Fridays events are ongoing, being held at the Museum Planetarium patio, I guess, on Main Street. Now you might think this is pretty bright sky for looking at anything astronomical, but often the moon is up in some position and there might be something else interesting to look at. It does stimulate, again, conversation, and the public outreach function is really useful for everyone. The September meeting will again be in person in this room, and it is a joint meeting with the Mississauga Centre, which was created especially because of a speaker that was arranged by Ed Wright, our secretary. The speaker is from the Canadian Space Agency, and he will talk about the James Webb Space Telescope. So hot off the press stuff there, and wanted to thank the Manitoba Museum for supporting the event by letting us use their Zoom account, which has a larger capacity than the RASC Zoom account does, because of that shared event with Mississauga. Spruce Woods Star Party is September 1st to 5th. It's a little bit longer this year. And you can register online so we know how many are coming, just to anticipate organizing the field and certain events. You don't need to pay online in advance, but you pay at the park. So make sure you bring checks or cash or something for payment. As far as the Glenlee site, our observing site, the dome is still closed because it needs to be assessed for repairs because of the flooding that was there, and there's currently a porta potty in place, so you can use the facilities. We have to get our own compostable toilet back up and running. There are lots of opportunities for people to volunteer, to get a little bit more involved in the RASC Winnipeg Center. We need a meeting coordinator, a coordinator of volunteers for things like outreach activities, someone to chair a spring star party. We have a really active star party organizing group for the Spruce Woods event. We'd like to start a spring star party as well. And explore the universe creator for the certificates that people can get, and they have to be reviewed and approved before someone receives that certificate. We would love to have a new webmaster, so someone with some skills in website design and content development and revision on a timely basis. A mentor coordinator, lots of meeting presenters, people who are interested in the finances of the organization, people who are interested in the observatory at Glenlee and maintenance and repair of same, especially volunteers to train new members to use the dome once it's back up and running, and light abatement committee. And Dennis has prepared a little bit more for someone who might not know what a light abatement committee would be about. This is a national committee, as a matter of fact, and it promotes dark skies and use of appropriate lighting so the sky can be dark, and works to promote the sky being dark and other preserves that are put together on a provincial or regional basis. We do have a new membership coordinator, Jay Anderson, and he will be taking over from work that Abdul's been doing for a while on getting new members oriented and helping current members renew registration. And just a reminder to renew memberships for the Spruce Woods registration and to sustain the communications that we have with you. And members observing night will be tomorrow. I think the observing committee, Brian, are you hosting that or going out?
I'm not sure.
Okay. Okay. Dennis had the slide out, so I think it's just a time when some people might go out there together. It's not really organized. There's no registration for it. You can just go, and if you need instructions how to get there, you can look on the website or in a newsletter. Okay, the next speaker is Brian Stash. What's up?
You have my presentation?
I believe we do.
Do the recognition. So I can think of the recognition.
Come on. Do we already have it up?
It's up. I just need
It's
the
up.
mic. All right.
And there's a laser pointer.
Yeah. How are you gonna use this equipment again?
Yeah, it's been a while.
Yeah.
Are you able to hear me out there?
Yeah.
Okay, just before Brian starts, while you guys are setting up, if I can just quickly mention that the park pass for this star party. So for the long weekend, it's a free park pass, right? But because we're going for 4 nights, the Thursday night, you actually have to get a park pass from Manitoba Parks. So just
Okay.
letting you know, so you don't get a ticket on your windshield. And yes, the weekend of the star party is also the dark sky preserve ceremony. So make sure everybody come out, check out your checklist, make sure you have everything ready, and we'll see you out at the star party.
Okay, I have to repeat that because I'm not sure people here could hear that, Sylvia. So the first point was Sylvia is the SWSP coordinator. And the first point is the park camping is free that weekend, but because we're going for 4 nights, you do need a park pass. Otherwise you may get a ticket, or you will get a ticket
For the
for
Thursday
being
night.
there that night, that it's not covered if, under the free weekend. And the second thing is that during that weekend is also the event for official recognition of Spruce Woods Park as a provincial park, as a dark sky preserve, which will be a really interesting event that Sylvia and a number of other people have been really involved in. Okay, thanks, Sylvia.
Thank you.
One more thing about the staff party for Monday morning or other time also, if anyone wants to bring in any baked goods, they are welcome to bring.
Oh, okay, so a member of the committee, I think, has
Yeah, I
said.
will be coordinating for Monday morning.
So Camilla has suggested that if anybody would like to, they're welcome to bring baked goods for the breakfast, I think, on Monday morning at Spruce Woods. Okay, over to you, Brian.
Thank you. Kind of getting your feet wet here because I've done this for a while. Okay, so what's up for August 2022? Let's see if I remember how to do this. Oh, oh. Wait, that. No, that's the point.
laser pointer button. Need the forward button.
That's what I'm doing.
I don't think the laptop.
Yes, it is. But you can just use the laptop.
Okay, really, mine just technically.
Yeah, it worked. You just have to press it.
Is it? Because it's not moving there.
Are we, how many copies of this do we have open?
It's, how do you extend the screen? Because which one?
It should be page down. There we go. Okay, so just
sorry?
take the, Ryan.
Yep. Nope.
Uh,
Okay. Well, I'll just use the.
I think it's up more than once. I saw more than one.
Or just use the-
Where's the mouse gone?
I don't
I'm
know.
trying.
There it is.
Did it work for Gary?
No, I mean, she didn't use this.
Oh, okay.
I didn't use that.
Yeah, she didn't use that. I mean, this is-
Of course, it
Oh,
has that.
that's what's in there. Okay,
Yeah.
all right. Okay, sorry, I didn't know that.
That's great. Thanks, Tom. Go hit F5.
Now,
There we go. Let's try this. And there we go. Okay, great. It's working now. Thank you. Okay, so let's, like I said, getting my feet wet here. So like, oh, actually, yeah, that works. I'm shocked. All right, that's supposed to be Mercury. Okay, so let's talk about what's up for the month of August. Okay, so this is what we have. When I say poor geometry for Mercury, what it really means is it's not really visible for the northern hemisphere, but quite visible for the southern hemisphere. So they're able to see Mercury. Venus is strictly a morning star or a planet, sorry, but it gets closer to the sun. For Jupiter, or sorry, Mars, Mars is going to kind of move from Aries to Taurus, and it's going to remain there for the better part of the year. It's going to move up a little bit slowly, but it's going to be rising a little later at night. As for Jupiter and Saturn, they're in a retrograde motion right now, but they're visible throughout the entire night, which is kind of nice. And I did check out last night, so they're nice and high for viewing. So Saturn, something special is going to happen for Saturn. It's an opposition, but I'll explain more about that later. Okay, for the August events, and when I was doing this slide compared to my other slide, nothing has really changed. The moon is always going to be a few degrees from these planets. We do have a double shadow transit for Jupiter on the 16th. Of course, the new moon is on the 27th. Like I said, Saturn is at an opposition or the closest point to Earth on August the 14th. Now let's move on a little bit. Now, all I'm saying here is Jupiter and Saturn. Saturn's going to rise sooner, right after sunset. Of course, we have the full moon tomorrow, which is really not an idea for observing, but and then Jupiter will rise a little later. But like I mentioned before, Saturn and Jupiter are visible throughout the entire night. Now, what's special about Saturn, let's see if I can call this from memory. It is at 13 degrees tilt. At August the 14th, it's going to be at the closest point to Earth. So, and it's going to take 74 minutes for the light from Saturn to reach Earth. And I was trying to play around with this. I was going to maybe do velocity over distance divided by time to figure out the distance. If we know the speed of light and we know the time it takes there, we can figure out the distance, but I'm not going to do that. All right. But what's going to happen is it's a 13 degrees tilt, but month end it's going to level out. So now is probably the time to see Saturn. Throughout the whole year, it's going to just shrink over. So I love Saturn. I had what's called my Galileo moment a while back before we did the one at the event. So it was good. I like Saturn. I would say somewhere like in January, I think it was, in the freezing cold, 3 o'clock in the morning. So I had my Galileo moment with Saturn. Okay, so like I said, Mars is going to rise a little later. It's going to pretty much stick in Taurus and constellation Taurus for the better part of the year, or up at least December. On August the 19th, I mentioned it's going to be 3 degrees of the moon. And nice thing about it, it's going to be near platings. Like I mentioned before, a lot of these planets are going to be just a few degrees on the full moon. And it's going to be like that for the better part. All right, now when I was looking into this, we have the Milky Way. What's going to happen, what's special about August, and if you do look, or you do like the Milky Way, which I do, and I'm planning on maybe next week to do a little bit more photography of it. That core right here, I have it, yeah. This core right here is going to disappear by month end. So if you want to look at the Milky Way, now's the time to do it. We do have Cygnus here. It's going to be directly over above. And if I go to the next slide, we have the North America right here in Cygnus. So again, this would be the month to look at the Milky Way. All right, what's next? Venus, like I said, it's going to be a morning star. I have here, it's at about 5:30. The thing is, we're going to have a crescent moon. And as far as I can tell from the model, that's probably the only time you're able to see the crescent moon. All right, now I touched this back in June about the twilight. It's almost over. So what's going to happen is I did lay it out for August. As you can see here, roughly about 10 o'clock, it's going to get nice and dark. We're going to have no more twilight. Well, we still have a little bit of twilight, but starting around 10 o'clock and to 2:15, you can see here it gets longer and longer, and we'll have some dark skies. So maybe we'll see the aurora. Maybe we can do some Milky Way shots or view it through your binoculars or your telescopes. But this chart here was supposed to indicate that I did back in June. This gray area, especially in the month of June, as you can see here, it'll never get dark enough because we're just at the 50-degree latitude. And unfortunately, summertime is not really a good time. Fall, from what I can tell from other people, fall is the best time for doing your observing. All right. Solar activity, I have been monitoring this for a while, and it's still, we're blowing the bell curve on this thing. So increased sunspots should mean increased solar activity, which means that we might see more aurora. And because we're getting darker now in August, it's a good time. So it'll be interesting to see. You can see right here, we're just blowing the predicted values. Okay, we do have, my point with this here is we have 2 meteor showers going right now. We have an aquatic, even though it peaked on 29, and we have the new moon, which is nice. But it's from July the 12th to August 19th. So it's still technically going on, but as for the next meteor shower, the Perseus meteor shower, it's from July the 17th to August 24th. So these 2 meteor showers are technically overlapping each other. So there's a really good chance that you should be able to see something. But unfortunately, we have the full moon. So it's not really prime doing for this meteor shower, but maybe next week, like I said, they are overlapping. Maybe there's a chance to see something. All right, so for the weather, I don't know what to say about the weather. It's off and on. I work in the Richardson building. I look at the weather all the time. every day it looks like it's going to rain, not rain, rain, not rain. But the temperature in this one shows that for the better part, it's going to stay relatively warm. So around 15 degrees, but on some days it's still going to get what? Like Friday right here, we're looking, see the yellow representing what it feels like, and the red represents the actual temperature. So on some days you can see here, it's going to be a lot hotter than how it feels. Now, what about the cloud levels? Well, that's a whole other thing. This looks like a roller coaster ride, as far as I can tell. So what nights are really good? Well, nearly nothing. Maybe Thursday might be a good time. I have Thursday right here, and that's not really showing up the way I want it, but that's okay. We do have a little bit of precipitation on Saturday or Sunday as the weather is predicted, but I think we might get something tomorrow. But in terms of amount, very little. Okay, so as I say, Thursday, there's a chance that we have a little break here, but Friday and Saturday, as you can see here, we do have some clear skies. So again, I'm making a point to myself that next weekend, I'm gonna head out and do some local way shots. Hopefully the weather will hold. All right, so again, that's what I have for what's up. I hope I see you guys out there. Thank you.
You want the light out?
Yes, please. Well, here we are again. I know we have one new member. Welcome. Any others? We're all regulars. We're all hardcore, all, oh, here we have two over here. I should let you see what I look like if you're a new member, because you'll see me in the dark sometime and you'll wonder who that silhouette is, but it'll be me or somebody like me. It's good to be back anyway. So I want to talk about eclipses, but I'm not going to talk about eclipses as eclipses. I'm talking about them. What do you do with eclipses? This is a diagram I made up a number of years ago, and Rick Feinberg found out about it in Sky and Telescope, and now it appears regularly in Sky and Telescope's little notes on the line about eclipses. What I want to talk about is these things to do at these two eclipses. And these eclipses are both going to be partial here in Winnipeg. The bottom one is what it will look like at maximum in October next year. And the top one is its appearance at maximum in April of 2024. And if you want to go see them, well, you can see on the maps that we have here that, let's see if I can push the right button here. Forward, back, link. I don't want to move, I just want the light. There you go. Okay, you can see here that, well, we'll start with the first eclipse, that it runs down through from almost on top of where the 2017 eclipse started, and runs down basically from Oregon to Texas. And the other eclipse runs up across the eastern seaboard through, well, from where it starts in Mexico down in here, comes ashore in Mexico, runs up through Texas, all around, kind of along the Appalachians, finally passing the suburbs of Toronto, over top of Montreal, and then off into the wilderness of Newfoundland and Nova Scotia and New Brunswick. And I say wilderness because of this, not this, so I'll get to that. This is a cloud chart I've made up that's on my webpage if you want to go look at it. And basically shows anywhere that things are green to blue is where we tend to have fairly low cloud levels. And anything that's in the oranges and deep oranges, you can see the scale on the right-hand side there. those are places where you get fairly high levels of cloud. So it's quite apparent that you might not want to run off to Oregon to see this. Although there are some, even there, the kind of yellowish tones they have show the average clouding is about 55%, which is pretty good. It's about the same or even a little better than Winnipeg at that time of year. But of course, you get down into the Four Corners area and back in through New Mexico in particular, you're into the blue shades and the weather looks pretty good. And again, all of the gory details are on my website. One of the easiest ways to see where to go is to take a look at a graph of the average cloudiness down the center line of that October eclipse. And you can see quite readily that there are places in Nevada and parts of Utah that look pretty good, especially when you get into the eastern part of Utah. You get down into, say, around Monument Valley, which is an exquisite place to go and watch this eclipse if you've ever been in that area. But you can also pick it up quite nicely in through the middle part of Nevada, right, in what they call the Great Basin. And it's a basin because it's surrounded by mountains on all sides. And so clouds have to get over that mountain before they can bring any problems to you. And once you get in, of course, into the Colorado Plateau down in here, all the way from Monument Valley, actually into the western part of Texas, you get a pretty low. In fact, one of the better numbers for anywhere going to eclipses once you get under 30%. And having said that, there are still lots of ways to get cloudy in those parts of the world. So you don't want to go and say, well, I'm going to Four Corners and I'm going to see the eclipse. You still have to keep an eye on the weather as you get there. When we look at the next eclipse, you can see that if you really want to see it, you go to Mexico. And I know a number of people are already thinking that they'll just go park in Mazatlan, which is a very good place to watch this. April in Mazatlan, that's probably a nice way to break the winter for us. But through central Mexico, it also looks pretty good. But once you cross in the border into Texas, it starts to get cloudier and cloudier until you get up into what I refer to as the wasteland and in around the Atlantic provinces. Because you can see the cloud levels there get up very, very high. And so you have to do a little bit of days before the eclipse looking at the weather forecast. And here's what the graph looks like for that area. You can see the very low levels are down in here in Mexico, and the higher levels, they climb pretty quickly once you get into start into Texas. And there are lower points in here. These are actually along the shores of the Great Lakes. So if you didn't want to go down to Texas, but you found your way into Ontario or into the northern states there, you'd stay on the south side of the Great Lakes, and then you get this about a 10 to 15% lower cloud level because the lakes themselves help to suppress some of the cloud. And that's all I'm going to say about the weather and where the eclipse is and everything else, because what I really want to talk about is what's on the next slide, is what happens during an eclipse. But I'm not going to go through all of these. I want you to read that slide. But this represents the total eclipse of April 2024, not the annular eclipse of October. Annular eclipses are nice. The moon moves right across the front of the sun, but it leaves a ring of sunlight. So it doesn't completely block the sun. So you don't get to see all of the goodies that you do when you get a total eclipse. And if you were here in 1979, you would know what a total eclipse looks like. It's assuming that your teachers let you out in the yard to watch it. Anyway, this is what a total eclipse would do. And you can see we have a lead-in time of 1.25 hours, and we have an exit time of 1.25 hours on this slide. And in between, we get, in our particular case, 4.5 minutes of totality, which is longer than normal. So this is a relatively long eclipse, a little more than 1 minute longer than the median length of a solar eclipse, total eclipse. And again, with the first sighting in the eclipse, watching the moon go across sunspots, you notice the lights start to change. It gets a little eerie feeling about halfway. As you get closer to totality, you begin to see Venus. If somebody usually will find it and you'll all be able to look at it. Other planets will come out. You can play with pinhole images, we do, but it's really when you get right up to totality, you've got this long list of things that you can see at the beginning and during totality, and also similarly going out of totality. And those are in 4.5 minutes are really packed with activity. And if you're going to be watching it, there are a lot of things that you might be looking for. And if you're going to be photographing it, you even got more problems with trying to absorb it all in that time. We have a saying in eclipse chasing that all eclipses last for 8 seconds. And it always seems like that. I know when I go to an eclipse and I'm usually the one in charge of keeping time for everybody, and I say halfway, and I hear all kinds of groans and already. So you need somebody or a machine to keep timing for you, so you're ready for the various things as they occur. So I want to start with partial eclipses, because partial eclipses is what's going to be visible here in Winnipeg. That means the moon is going to go only partly across the sun. And we saw in my initial second slide, I guess it was, how much of the sun is going to be covered by the moon. So about half here. So if you can't go traveling to see the annular part of the eclipse, and annulars aren't as interesting as totals, then you'll have to be content with what a partial will give you. And if you are going to go see the total eclipse, of course, the beginning and end of a total eclipse is always a partial eclipse until the moon actually gets right on top of the sun. So there's a lot of words in here, and I don't want to belabor them too much. You can read them for yourself, but there's just a couple of little hints. They have a limited appeal. Partial eclipses, I know people who will travel around the world to see any partial eclipse, but that's a little bit driven, let's say. To go to the tip of South America to see 10% of the sun covered by the moon in the middle of winter seems to me to be something that's done for reasons other than just because you want to see a partial eclipse. You can hold your finger up over the sun and see a partial eclipse like that. But when you've got that event here in Winnipeg, what are you going to do with it? Well, you can go out with your eclipse glasses, and we are arranging to bring in a large number of eclipse glasses to distribute to the membership and to everybody else until the supplies run out. But you can look at it, and that's fine. I mean, but I'd like you to remember that that partial eclipse to you, which is kind of, oh, well, I saw it, you know, spent a couple of minutes looking at it, maybe when it starts and when it ends. But that partial eclipse was a pretty terrifying event back in medieval Europe, where any kind of impediment to the sun had its messages, usually religious. And of course, if you go back into Babylonian times, that message was even more extreme, except for the people who were advising the various rulers, because they knew it was coming, or at least suspected it. And they would always come up with some little prediction to the king, queen, or whatever, of whether it was a good omen or a bad omen. And of course, eclipses in those days, it wasn't just the eclipse. It had to be an eclipse and a thunder shower at the same time to be really ominous, or an eclipse and an eagle that captured a bird, which was a good sign, and so on and so forth. So think about the history a little bit when you're watching that moon cover part of the sun. Many of you, maybe most of you, will probably try some photography, and the way cell phones work these days, just crazy what they can do. Especially I take pictures with my expensive Canon, and my wife takes pictures with her expensive cell phone camera, and hers always look better than mine. partly because of all the processing that Apple and Google and the rest of them put into their cell phone cameras to make things look good. But if you want to do, say, a time-lapse video, well, it'll just show the moon moving across the sun. But it's a video and it has an extra dynamic to it. And so you have to think about how you're going to do that. You know, you're going to be following the sun. So that means you're going to need a tracking mount. You need to know that you're not going to run into trees or anything like that. Or maybe that you are going to run into trees because that's part of what you want to do. Clouds, I always say eclipses are way more interesting when there's clouds around. And if you're just before the eclipse and there's clouds around, everybody is panicking, but after it's over and they manage to see the eclipse and the clouds perform this beautiful framing job, then everybody says, wow, sure looks good with those clouds in the sky. So there's a before the eclipse impression of cloudiness and there's an after the eclipse impression of cloudiness. If you want to take a picture of the eclipse with some kind of foreground in it, even yourself, maybe you and your family with the eclipse sun out the behind, you have to know, of course, that if you've got a solar filter on your camera, maybe you took the pair of solar glasses we're giving out and stuck them on the front of a camera so you could photograph the sun. You have to know you're not going to see that foreground because so much of the light is cut out by the filter. There's nothing there. So you have to think about doing things like a composite photograph where you photograph the sky or the scene that you want without the filter, and then you put the filter on. And that's a little bit of a trick when it comes to compositing those two, unless you take the picture without the sun in it the day before, and then the next day you stand in the same place and take that picture. And then you just keep the filter on. That's not really cheating. I know if you saw the, back in '79, there was a picture of the total eclipse over the Golden Boy. Well, the photographer that took that told me he overexposed it. So he put a little dot of ink in the middle of the sun to make it look like a solar eclipse. So he got the corona, but the rest of it didn't turn out the way he wanted. So he modified it a little bit. Now we can do it digitally. Sometimes making the foreground the center of attention is more important than the eclipse itself. And if you've got clouds in the way, you can take a picture with the filter off if the clouds filter the sun just right. So you might want to watch for that kind of a moment. The main thing is you have to pay attention a little bit because the sun's an extremely bright object and the scene that you're setting it in is not. So here's an example of somebody. Well, of course, we aren't going to see a partial eclipse at sunrise, but here's where the eclipse itself is just another partial eclipse, but the setting makes this fantastic picture. But you don't have to get all that complicated. Sometimes just the sunspots on the sun. This is a partial eclipse from a number of years back that Stan and I attended to in New Mexico. We had the advantage of being quite high up in the mountains on this one, so the air was very transparent. But to me, this is one of the more beautiful eclipse pictures that I have because the sunspot group was so nice. And of course, we're now, as Brian showed you, coming up fairly strongly in the sunspot cycle. So we may actually have a pretty good set of sunspots on these. These require just the right exposure. You don't want to overexpose. So take a bunch of different exposures, or if you have a sophisticated digital camera, watch the histogram on the back of it to make sure. And you can point your cell phone camera down the eyepiece tube and take this picture if you want, or you can have a regular camera attached to a telescope and do it. Usually people like to take a picture of first contact, which is the first moment that the moon's disk becomes visible on the sun. Well, that picture on the left, first contact picture, is like boring. Doesn't get more boring than that. There is actually the moon on the sun. You can see in the second picture where it's coming in, and there's just a slight fraction flattening of the disk there. But that would not make for a very interesting picture. But if you put it as a combination, and like this top left here, that's pretty nice little sequence of a solar eclipse. The exposure is nice. You can afford to take 4 or 5 pictures of each one of these as you go through the cycle, and then just match up the brightness of each one so they look the same. If the sun is sinking, it's going to get a little darker as it goes along. And so you might want to think about whether or not to adjust the brightness. But that's partly in composition. The one on the lower left is one from 2 years ago. This was actually the end of a total eclipse, but the fact that it's silhouetted against distant trees actually makes for quite an interesting picture compared to just the sun by itself. Silhouetting the moon or the sun, the moon and sun against some object is good. This is an eclipse that's about 28 degrees high, so it's going to be sort of that angle in the sky. You should be able to find some objects that you can, or you can take it in H alpha. There's a number of H alpha telescopes, and then they get kind of a different perspective on what an eclipse looks like. If visually, you might want to actually examine the limb of the moon very, very closely to see if you can see the undulations that represent the mountains on the edge of the moon. It'll take quite a bit of magnification to do it. And if you get lucky, you can have clouds in the sky and still get yourself a partial eclipse picture. That looks pretty impressive. Just for a little few clouds. So don't think about the annulary or the partial eclipse as something boring, but think of it as a bit of a photographic challenge to say, hey, where could I go? What could I do to make this thing into an interesting picture? For instance, could you do something with this over in St. Boniface Cathedral? I actually don't think that would be a really interesting picture, unless there's some clouds in the sky that are in the background behind that. And then you sort of have 3 depths to your picture. You have the cathedral, you have the clouds, and you have the sun itself in the back. And here's a program called the Photographer's Ephemeris that you can free to use online, or you can pay for it and download it into your computer. This is for October the 14th at 12:04 p.m., which is slightly after maximum partial eclipse. And I put this little red pin right here. This is Memorial Boulevard right here. And this is the direction to moonrise and sunrise. And this is moonset and sunset. And this is where the sun is right now. And the moon is actually right under it because it is an eclipse. But you can't quite see it very well in here. But this stuff right underneath is the legislature. What's on top of the legislature? You do the golden boy with the solar, with the partial eclipse in the background. And if you do it just right, and you just have to slide up and down on Memorial Boulevard until you're just the right angle, you could snap golden boy in front of the moon, and you would see him even though you still have the solar filter on. You might also want to try, I don't know, maybe go over to Garbage Mountain or the Juba Mountain, Garbage Hill there up by Polo Park, and photograph across the city. But I don't think the angles are going to be right for that, because you'll be looking southwest and you actually want to be looking south for the eclipse. But you might find something, the bridge, the museum well, any of the museums actually that we have in town, you just find interesting vistas. Even down the street, just shoot it down Portage Avenue, long telephoto with the eclipse sun there. Lots of things. Use your imagination. Those you can do with your cell phone. You can get a little bit of a solar filter and put it over the cell phone. Another thing to do is this kind of a montage. This is something that is pretty easy to do. It's from a 2020 eclipse photograph from Judy, and I put it together into this. Well, a lot of people do this. It's interesting, but it's not particularly exciting. But there's a little difference here. I mean, this is an annular eclipse here. I think it's not 2020. Yeah, but there are times when annulars are more interesting than others, but I'm here mostly to demonstrate what happens over here. It went behind some trees at the end. So now when I look at this, I know exactly what eclipse it was because there's some marker in there that's not just another annular eclipse. Well, what can you do? We're not going to go behind the mountains. But what happens if you photograph that partial eclipse in among a group of trees and you took composites as it was in the different places? Sometimes it's fully exposed, other times it has part of the trees. That'll take a bit of planning, but a nice little sort of, you can go out to Assiniboine Park and find a couple of nicely positioned pine trees or some kind of coniferous tree, for instance. And you set yourself up so that you can go the day before. You'll know that you'll see where the sun is and check the times, make sure that you've got some moments where you clearly see the partially obstructed sun, and other places are in clear. Put it together into a composite that shows the thing going across the sky, but with the trees in and out of the trees. You think outside the box a little bit when you're trying to do these things. Well, this is an annular eclipse. And so this one is where what you would see if you went down to the American Southwest to watch that October 2023 eclipse. And one of the big challenges with annular eclipses among the people who do a lot of this is that, can you see prominences and the corona during an annular eclipse? The sun is never completely covered, but there are moments when the moon is blocking the edge of the sun. So in this case, on the left-hand side, it's as if you had a total eclipse on the right-hand side of the sun, and then on the right side of the image as if you had a total eclipse on the left-hand side. So if you were to zoom in or adjust your exposure for whatever is along that limb, would you be able to see prominences and chromosphere? I think you can figure out the answer to that is yes. But there are other things that happen when the sun and moon are right on the edge too. The moon is not a smooth ball. It has mountains on the edge of it, and those mountains and valleys on the edge are places where the sunlight is alternately blocked and where it's also shows through those mountains. So here's a picture of the so-called Bailey's beads, which are these little beads that lie right at the moment when the sun and the moon are tangent and they're just moving. And these beads move because, of course, the moon is moving across the sun. And so the valleys are initially exposed a tiny little bit and then they expand. I'll show you a little movie on that later on. So this picture is taken without a filter. If you have a digital camera that's mirrorless, I know every time I start my Canon mirrorless camera, it says, do not point this camera at the sun. So this is not a kind of picture that I would take with one of the newer mirrorless cameras. And you might have the same thing if you have a Nikon or a Sony. But the older digital cameras, Canons in particular, and they can do this. They don't burn the sensor up when you do this, but I wouldn't leave it. I'd have a cover on it, take it off, snap the picture for 5 or 10 seconds and cover it up again so it doesn't overheat on the sensor. I don't think it'll damage it. I'm not going to write you an insurance policy on it. Obviously, the person that took this didn't worry about what they were doing. It doesn't tell me what kind of a camera that he used. Anyway, you can stop the camera down. The thing is this is still a little too bright. I went to an eclipse once and I put a filter on before the eclipse got to this stage, and I said the guy I was with, it's so brilliant on my camera, I can't see anything. And he says to me, the sun is brilliant. By putting the filter on, you lose that effect. So this is what it really looks like. Now, if you had cast iron eyeballs and we're looking at this thing, this is what you would see. Of course, we don't want to look at that. You could theoretically look at the that little top edge with a certain amount of danger. And I hate to admit that I've done it, but it's the definition of dazzling. So anyway, so we got this moment when the limb of the sun and the moon are tangent to each other. You get beads that are the sunlight shining through the valleys on the edge of the moon. They're blocked where there's mountains. If you have a filter on, it still appears, here it is here. But you have to go to a longer exposure and it loses some of the drama, although this picture also could probably have used a bigger telescope or a little more magnification. So those moments in an annular eclipse where the beads are most active are precious moments, actually. If you really want to see the beads in action, you go to the edge of the eclipse where the eclipse is central. And then the beads won't just appear and then disappear and then reappear on the other side, but will appear to roll around the edge of the sun and the moon, or along the moon's edge by the sun. So those, what we call the edge beads and the edge time lapse and that sort of thing, they're the ones that are really the most interesting. But very few people go there. Most people want to be right underneath the eclipse, in spite of the fact that there's really much more happening out on the edge of the track. Now, I said initially, can you see prominences and the chromosphere and the corona? And here's an example of a picture that did. And you can see that in this image, I should probably turn on the pointer here, but just leave that alone. Anyway, I'll do that, won't appear, so I'll do here. You can see here we have the chromosphere, which is a layer of the atmosphere of the sun, extremely red in color. If you have a hydrogen alpha filter, that's what you're looking at, is chromosphere. We see here traces of the corona here and here, and there's no prominences in this picture, but there is one in this picture here. You can see a bead with a prominence. So there is this precious few seconds where with an unfiltered camera, you can, the daredevils do this sort of thing. And of course you can never see this by eye because you'd have to be looking at that part of the sun. If you had a way of blocking off that bright part of the sun, then you could, for that instant, see it visually. What that gets you is bragging rights on Facebook, and that's about it. So it's not all about cameras and watching. There's some other things you can do, and this applies. I don't know if there would be a temperature change at Winnipeg, but there might be. It might be worthwhile measuring the temperature during the eclipse to see whether there's a little dip or not. I don't know if it's been a big enough eclipse to actually do that. And I'll show you why in a minute. You measure color changes. People say to me, oh, the color of the sky changed. Well, what was it? And somebody says, oh, it's much bluer. No, it's more gray. I thought there was a lot of red. You know, you could just take an ordinary digital camera and photograph a white piece of cardboard and then check the RGB signature of it in software after we're done to see if there was more red or more blue or even more green in the image. There's little controls you have to do. You can make pinhole images of the sun. That's good for kids. You can see how clouds change. That's sometimes a school project. I always find it nice to download satellite pictures and watch the shadow moving while I'm also watching the eclipse. You'll notice, especially when you get into annular and particularly total eclipses, that shadows change their sharpness. You can see what happens to people around you. You look for shadow bands if you're down underneath the main part of the eclipse, not out here. Lots of little tricks you can do. I measured temperature for a while. Here's one of my setups. You can see I've got a sensor that's on top of this. It's about the height of my shoulders. And I have another sensor on top of this beer bottle, which was full. And I couldn't drink it after the eclipse because I still had to make temperature measurements. Because you'll notice I have a sun shield on this thing so that both of these temperatures are measured in the open, but shielded from the sun. So the center, the shade is here, the center is just dangling in here a bit, and it's just dangling off the top of that as well. Because the different temperature changes at the ground. So here's where we are. It's in the morning, the ground temperature is colder than the temperature at the higher. And as the sun comes up, they get closer and closer, but just as they get equal to each other, the eclipse started here, we're halfway on our way to totality, and now the ground starts to cool off again. And the air temperature also cools, but not as rapidly. And finally, after the eclipse with the sun coming back, they both come up to be the same temperature. And this is an inversion, essentially, that forms at the ground. And if you look at it a little differently, where I took the difference between the two, you can see on this side, the upper sensor is warmer. They get almost to the same temperature. And then the upper sensor got a lot warmer because the ground cooled so rapidly. And finally, when the eclipse was almost over, the two temperatures became pretty much the same. Well, that's something that happens every morning under clear skies, but to watch the temperature differences spread apart and come back together during the eclipse is something that's pretty easy to measure. And you don't have to be under totality or centrality to do that, but you have to probably have more of an eclipse than we're going to get here at Winnipeg. A lot of people like to make these pinhole things, and here's a picture. You can see Judy interlacing your fingers here in the crescents of the sun that are appearing. And so you just have to hold your fingers together like this to make little gaps between them. And kids like to have a lot of, other people bring a colander along and let the images of the sun shine through it. Some people draw diagrams and things like that. In a central eclipse, I like to have a little gizmo. I have one here that I can look at the eclipse, and you can see on this diagram that there's 4 parts to it. The top part is a regular solar filter that I can just hold up to my face and look at the sun. And then underneath it is what's called a diffraction grating. And a diffraction grating breaks light up into its colors. I'm going to pass this around. And if you look at the lights on the walls here, you'll see that they break up into a series of colors. Those look like orange lights, but they're not. I see a red and an orange and a green and a blue. So what this is doing is it's splitting all of the colors that are given off by these lights. So you can see that although they appear to be a single color to our eye, there's actually 4, and in fact, deep purple in there. So there's 5 different images of it. Well, some really crazy things happen during a solar eclipse, total eclipse with this, and I'll talk about it. Also have polarizers because the light polarization in the corona changes during an eclipse. But you know, you don't have to build a gizmo like this. If you've got polarizing sunglasses, just put them in front of your eyes and rotate them while you're looking at the eclipse. So you can pass that around, look through the second hole with the lights behind in particular. And you'll be able to see, now when you do that an eclipse, of course, you break the sun up into its colors, and we'll get to that in a minute. The sort of thing that drawing an eclipse doesn't seem to be a very common practice, but you go looking around, you find people who did it. And I know there's some of us who likes this. And the thing is as an artist, you can make any kind of a foreground that you want, because your art and your visual senses, you have the glasses on, you see what the sun looks like, you take them off, you see what the scene looks like, and you put them together. You do a composite at the time. This one in the center is one of Judy's drawings, and so is this one out here, just what the eclipse looked like visually as opposed to what it looked like photographically. I'll tell you right now that when I look at eclipse through a telescope, during totality, where the filters are not on it, that no photograph has ever been able to duplicate what I see. The delicate nature of the inner corona of the sun, the beautiful layering of the different parts of it that you can see. there's a lot of things that you can do photographically, and I'm not really going to go through them at all. Mainly it involves planning. It means going in with an idea of what you want to do rather than just banging off a whole bunch of pictures. And a lot of people have a computer that does their programming, their triggering for them, and those are fine because that means you get to watch it while the computer is doing all of the work goes on. But of course, what comes up after that is what you do with all of those images that you've got and what is it you actually want to see. Most people seem to me to go into an eclipse without a clear idea of just what it is most important to them. Do you want to see the corona? Do you want to see the chromosphere? Do you want to see the prominences? And then, of course, there's all the things you can do on the landscape. You want to see the shadow coming in, you want to photograph it. You want to keep an eye on people. Some of the best eclipse videos I've seen are eclipse videos that showed just people. There are a couple of things that work for you. The aluminized filters are so thin, they don't change the focus. So you can focus on the eclipse and then just take the filter off. The filter should be loose so you don't jar your telescope if you're doing it with a telescope, and so on and so forth. This will be available online so you can read them. But let me show you one of the things. Judy likes the beads. And so here's a sequence of images, sequential, 1 second apart. So here we are watching the beads gradually form and disappear as we go, and the moon gets more and more across the sun, starts to break up into parts now. So these are different valleys, different valleys. Now you can see there's quite a few of them through here. The beads are getting even finer and finer as they disappear. So what do we got? We got 9 seconds here. And those are shooting because there's no filter on the camera. Then you're shooting this as 1/8,000th, or well, in this one case it wasn't actually. The numbers are there. They're an 1/8,000th of a second, but camera had the potential to go to 600 millimeters, but was shot at 300. And part of the reason for that is that if you zoom in too much and you don't want to touch your camera because you don't want to fiddle with the focus or you touch your lens, then if you're zoomed in too much, you miss the outer part of the corona while you're focusing just on the sun. So it's probably better not to zoom all the way in. At the same time, here's a sequence that's done after the last ones were done. And you can see how the sequences changed all from way from 1/1600th of a second down to a 25th of a second. And these are not on a tracking mount or anything. And I think you can see on the last one at 1/25th of a second that it's starting to get slightly oval shaped. But in the upper right corner is what happens when you put all of these together with somebody who knows what they're doing a little better than we do. And it can make this lovely composite out of it, which is actually very close to what the eye sees, except that the eye is not showing you incredible detail that's in here. It's kind of swamped out a little bit, but that's about the size of the corona. So yeah, I need to think about this. Do I want to have a really fast sequence right at the start? Because if you do, there's going to be things you don't see because you're going to have to change your camera. Unless, of course, you've got a camera that's controlled by a computer. And then it'll do through this sequence of longer pictures. For the most part, I suggest that people start the first half of the eclipse going to longer and longer exposures. They stop when they're done. It takes a minute to do this. You have a 4.5 minute eclipse. You can spend 2 minutes watching that eclipse, watching it, pull out your binoculars, look at it. And then in the last minute and a quarter, you can do the sequence in reverse. So you start long so that when the eclipse is over and you get to what we call a diamond ring phase, you're at your shortest exposure and you're ready for it. That's the kind of planning that you have to do. I like all sky pictures of eclipses, but one of the things you can do is watch the shadow. See what happens around you. In the lower right there, you can see we have sunset colors all around us The one in the upper left is before totality. It hasn't quite formed there. You actually visually feel like you're in the middle of a shadow. Totality in 2024, the planets are there. The only one I think that's worth watching is Mercury, which is in close to the sun and which most of us don't see very often. If you want to fixate on Jupiter, well, just wait till sunset. It'll be there. Or if you want to see Venus and Saturn and Mars, as Brian showed you, just sunrise, go out and have a look at them. Don't waste your time on a solar eclipse looking for planets. You can see it other times of night. Shadow bands are interesting. They're like ripples in the atmosphere that you see as shadows flitting across the ground. And they are really the closest counterpart to that are the shadows on the bottom of a swimming pool that you see only. So here's a picture from 1870 that shows what they looked like on the walls of a house. Up until the digital era, they were very difficult to photograph because film was not fast enough and they were moving so quickly. They're actually moving at the speed or some fraction of the speed of the winds in the atmosphere above because they're little turbulent eddies being carried along in the wind. They're localized in Bolivia many years ago. There were some people that saw them 100 meters away. People didn't see them, but that's an exception, not the rule. Annular eclipses, a little bit open as to whether you'll see them. I think you need the very narrow crescent of a total eclipse, and it's only for about a minute before and after totality that you see them. But here is somebody that took a little picture of them just rippling across the ground. The big problem with watching for shadow bands is that you have to look at the ground while some really interesting things are happening on the sun up behind you there. So it's kind of like a mug's game. You either do it when you got a really long eclipse, or you wait till somebody yells shadow bands, you take a quick look, and unless you've seen enough eclipses. I said to watch clouds. Well, here's some observations by school kids in an annular eclipse in 1994, and they were looking at cumulus clouds and how they started to build in the morning, dropped off during the eclipse, and then came back up. Again, a good project if we happen to have a day with cumulus clouds. And here's a little video that shows the eclipse in 2017 that many of us saw. You can see in the morning before the shadow, the eclipse is, I think we're gonna just stop that guy if it'll pay attention to me. It doesn't like me. So you'll have to see they're building, then they're gone, and then they build again. So the cumulus clouds are very susceptible, but look at these thunderstorms up here. They start to build on this front and they just keep right on going. The same down in here, there's some thunderstorms right here that are down in Illinois, I guess. Hold on, where's some thunderstorms that are building here, and they just kept right on going right through the eclipse. So big convection doesn't change, but the little stuff up in here disappears and then comes back fairly quickly because these are 10-minute time steps. And this big long line of thunder showers here, they didn't even blink when the eclipse went by. If you look at the shadows, you know that when you think about it, the sun that's in mostly eclipsed has got along one direction, it's got almost the full width of the sun, and on the other one, it's a very narrow feature. So in one direction, you get very sharp shadows, and another one, you get fairly diffuse shadows. So this unknown person here, whose hair is suspiciously like mine, at the top, has sharp shadows on one direction and not on the other. I mean, let's face it, you're looking at your own hair on the ground. How interesting can that be? Except that you're not in totality at the time, so it's just something to do. I want to talk about diffraction grading again. When you look at the sun normally, it's like that little diagram on the right of the right. The light's coming from the photosphere, that's the surface of the sun, and it goes through this thin layer we call the chromosphere, which is mostly a reddish color. And when it goes through that layer, certain wavelengths of light are taken out of the sunlight that's coming toward you, and it leaves little blank spots in the spectrum, just like we were looking. If we were looking at the sun and certain conditions, we'd see the little black lines. And those black lines are made by the atoms and sometimes the molecules that are in the atmosphere of the sun. But when the sun is almost completely covered over, as it is on the left-hand side of that, the only thing that's showing is that chromosphere. There's now no light coming from behind it because you've blocked all that light up. So now instead of seeing places where the light's been subtracted, you see the light glowing in those places where it had previously been subtracted. This is called the flash spectrum. And it's about a 10-second event. And I watched it many times at eclipses visually. And I still can't grasp because so much is changing so quickly. I can only remember the larger details. So if we look at a normal, this is a prism that I've taken a picture here at the top, and then in the bottom is one with a diffraction grating, which is what you were looking at the lights around here with. Diffraction grating does a much nicer job. So where it says 0 order there, that's an actual image of the sun. That's the light that's come through the diffraction grating but has not been diffracted. So you could actually look through the diffraction grating and watch the eclipse on one side while watching the spectrum on the other side. And look what you see in the spectrum. You see all those curved lines. Those are lines of emission, light given off by the chromosphere right on the edge of the sun. And it's only on the left-hand edge of the sun that it's showing. So they all have the curve in them that mimics the shape of the sun. Now you can use a diffraction grating, like you can see one there in the top right corner. Those things cost, I think, about $5 at the university bookstore here. So if you're gonna go to a total eclipse, you should definitely go and spend that $5 and pick up one of those and have a look at these rather magical events. So how does it happen? This is what's called a direct vision spectroscope. That's something you could just pick up and look at the sun and you'd see those black lines coming through it. And what it is it's got a little slit on the right-hand side. It has a lens, it's called collimating, just makes all the light parallel, goes through the diffraction grating, and then you need a lens at the other end, which in this case is a human eye. And I have one of these and I'm gonna pick it up and look at the sun. And you get to see what you see. This is the absorption spectrum. You can see the little black lines in the sun's light, which represents all of the atoms that are in the sun. Now think about what happens in the eclipse. First of all, you don't need that little slit that was in the start of it, right here on the left edge, where it says slit. The reason you need this slit here is because each one of these lines is actually an image of the slit. So if you have straight line slit, you get straight lines. If I made a curved slit, I'd have curved lines. Well, when the sun is this narrow, it acts like a slit. You don't have to make a slit because Mother Nature's doing it for you by cutting off all of the sun except a very narrow part. So you can get rid of the lens that's up the front and everything else. You put a diffraction grating in, and of course your eye acts as a lens. So that's why that simple diffraction grating will show you all those nice lines on the sun. And it's actually a really simple way to get into some very intriguing physics. These things change in the 10 seconds. So some examples of the change in somebody's sequence of photographs. And you can see that initially we have a bright spot on the sun on this top image of the sun, and so you get this continuous spectrum here, but already you're starting to see some of the curved lines which represent the material that's in the chromosphere. And then as you get a little deeper into eclipse, this is gone, and now we're starting to see a whole bunch more lines pick up in here. This is done fairly simply, just a diffraction grating in front of 150 millimeter lens or something like that. The point is that when you watch this visually, these things are really, really changing a lot. You'll notice some lines are long and some are short. The long lines are stuff that's high up in the atmosphere or the chromosphere, and the short stuff is the stuff that's low down in it. And so not only are you seeing what elements might be in the sun, but you're seeing how they change from one level to the other. Or at least you're watching it, knowing that that's what's happening, but it's, so much is happening as these things expand and contract that when it's all over, you think, well, I remember a red line and a green line, and that's about it, which is why a video. And during totality itself, you can actually see the spectrum of the corona, which is round here. So there's a round one up in here, and there's a very faint round one here. These are just the curved ones by themselves are prominences on the edge of the sun, which is hydrogen emissions. So for $5, you get to play with some very sophisticated physics. But if it's your first eclipse, don't do it because there's so much else going on. So here we are at the end, back to where we started with where the eclipses are. How far you have to travel to get them, you know, it's for the October eclipse, it's max 2 days travel. If there's two of you and you're not inclined to stop, it's 1 day's travel, and a comfortable 1 day's travel. And the same is true for the 2024 eclipse, but you'll be very advised to find a good weather forecast and follow it for a few days so you get into a clear spot. And the cloud statistics are ominous, but there will always be places expected to be clear that were cloudy and places that are expected to be cloudy that turn out to be clear. So I hope I've given you a couple ideas if you're just going to stay home or if you're going to travel. I know a number of people thinking about get together, going down, seeing the October event. But if you're going to do one or the other, make it interesting for yourself and get yourself a couple of good memories to share with your family and your kids later on. Thank you very much.
So questions, and I can monitor the chat on Zoom.
So who's going? There you are. I guess we're going. Are we going?
I guess so.
I think it'll be somewhere in the 30s for us for eclipses. So we've seen a few of them. And I watch. Judy does all the photography, so I hope I've given her a couple of good ideas here. I know that if I was here, I think I'd be looking pretty seriously at that forest idea that I talked about, where you get in the trees somewhere with a little bit of an opening and gaps over here and just photograph that thing, put together a multiple exposure. I think that could work really nicely.